Here we have a 5-digit number, 72350, which we're going to repeat 7 times to get 49-digit number. And what we are asked to do is to remove 2 digits from this number, so this number is divisible by 15. And we are asked to count how many ways we can do that. So first thing we're going to do is to review what it means to be divisible by 15, and that's pretty simple. Divisibility by 15 means the number is divisible by 5 and by 3 at the same time. Divisibility by 5, it's simple. It means that the last digit is either 5 or 0. Now if you look at this number, you find the last 2 digits are 5, 0. So as long as we don't get rid of these digits at the same time, both of them, we are having a number divisible by 5. Now, divisibility by 3 means that sum of all digits we have here is divisible by 3. So let's count that sum. Sum of this 5 digits will be 17, and it's repeated 7 times, so the total number is 119. If we divide 119 by 3, we get a remainder of 2, and we can write it this way. How do we convert 119 into a number that's divisible by 3 by taking 2 digits out? Well, one way to do it is to simply take out 2 digits, so the number 119 reduces by 2 and becomes 117. And we're taking out 2. And also notice that if we take out 2 plus any number divisible by 3, the resulting number is also going to be divisible by 3. So if we take 2 and 3, so we take out 5, we get a number divisible by 3. If we take 8, we get number divisible by 3. If we take 11, we get number divisible by 3. And if we take 14, we get number divisible by 3. There's no reason to go beyond 14, and that's because that's the maximum number we can take out of 119. And the reason for that, if you look here, the maximum number here is 7, and we take 7 2 times, so we take out 14. There's only one way to take out 2 points from that big number, and that is take 0 and 2. If you want to take out 5, there are 2 ways to do it. One way to take out 0 and 5, the other way to take out 2 and 3. To take out 8, there's one way, and that is take 3 and 5. It is not possible to take out 11 with the numbers we have here. And to take out 14, we have to take out 7 twice. Let's count the ways we can get rid of 0 and 2. There are 7 zeros in this number and 7 2's. So there are 7 ways to take out 0 and 7 ways to take out 2. For every 7 ways we take out 0, for every one of them, there are 7 ways to take out 2. So the total number we have is 7 times 7, that is 49. Now let's look at 0 and 5. Similar story, there are 7 zeros, 7 5s, so there are 7 times 7, 49 ways to get rid of 0 and 5. However, we need to remember divisibility by 5. We said we cannot get rid of 5 and 0 at the end of this number at the same time. And that would be one of those 49 ways to get rid of 0 and 5. So it means that the number that we can use to get rid of 0 and 5 is actually 49 minus 1, which is 48. Now when it comes to 2 and 3, again, there is no other restrictions on 2 and 3, so it's 7 times 7, 49. Similar ways we're going for 3 and 5. For 11 there are 0 ways. And now the last thing we need to count is how many ways we can get rid of 7 and 7. And here let's review a little bit of combinatorics. If we have k identical balls and we want to put them in n distinct slots, if we're counting number of possible ways we can do that, that is the number of combinations, and there are, like, at least I know 3 ways to denote combinations, and this is the formula you would use for that. So when we have 7 and 7, we're talking about 2 identical balls, k equals to 2. A number of slots is the number of 7s in this number, and that is 7. So number of ways we can get rid of 7 and 7 is 21. And the last thing we do, we just add all these numbers together, and we're saying that there are 216 ways to remove 2 digits to make this number divisible by 15.